In this video, I'm going to explain what is potentiometer and how to compare the EMF of two cells using potentiometer. Potentiometer is a device used for accurate measurement of potential difference, current and resistance. Potentiometer consists of a 10-meter wire stretched on a wooden board in parallel rows like this. 1 meter, then 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10-meter wire is stretched in a parallel rows. Then one end is A, the other end is B. So this is what is potentiometer. So end A and B. So potentiometer is represented, and this wire is constant or magnetic. In meter bridge also the wire is constant or magnetic. It's a resistance wire. Then end A, you connect the positive of the battery. You connect the positive end of the battery to the end A, and the negative end to the end B, and this is the key. So this is the primary circuit, and here you connect a primary cell, maybe Daniel cell or a Lagrange cell, then galvanometer, high resistance, and then jockey. With the jockey you can make contact at any point on this wire. Then there is a potential difference between these 2 points, because positive and is connected here, and there is a potential difference. When the potential difference between the point A and J is equal to the EMF of the cell, the galvanometer will show zero deflection. The reason is a positive to negative. This is sending current like this, and this is a potential difference. Because of this battery, this end is positive, this end is negative. So it is like two cells connected in an opposite manner. So current will become zero. You adjust this jockey. So at one point, galvanometer will show zero deflection. At that time, EMF of the cell will be equal to the potential difference here. Potential difference is IRL, where R is the resistance per unit length of the wire. If you multiply by L, so this is the resistance of this wire. Then current, according to Ohm's law, potential difference is equal to current multiplied by IR, resistance. Resistance of this wire is RL. So this is the principle of the potentiometer. EMF is proportional to the length. So when EMF is more, the balancing length also will be more. Using potentiometer, we can compare the EMF of two cells. So this is a circuit diagram for that. So this is the primary cell. Here a battery is connected, key, then a rheostat to adjust the current through this circuit. So here there is a rheostat. Now positive should be connected here. Then here there is a 6-way key or a DP-DT. DP-DT. This is DP-DT. Double pole, double throw. Then here you connect a primary cell, Lagrange cell. Here you connect a Daniel cell. Lagrange and Daniel cells are connected here. Then if you close this circuit, this primary cell will be included in the circuit. Here, if you close here, this cell will be included in the circuit. By closing this side, move the jockey on this wire. At one point, galvanometer will show zero deflection. So then EMF of this cell will be equal to the potential difference across this wire. So IRL1 in the first case. Next, you close this gap, this, and E2, this cell will be site 2 will be included in the circuit. then again you find the balancing length by moving the jockey. Then at that time L2 is the balancing length. So as per the principle of the potentiometer, psi 2 will be equal to IR L2. Now you divide this equation by this equation. So psi 1 by psi 2 is equal to L1 by L2.